Good morning to everyone. We are from Gitbus, and today we are presenting our assignment 1 project, which is called a system called Gitbus. Gitbus is a real-time campus bus tracking platform, which is the idea is simple. Instead of students standing at the bus stop with no idea whether the bus is 2 minutes away or 20, Gitbus gives everyone, like students, drivers, and me, a shared live view of what's happening on the road. So without further ado, let's get started. So firstly, before we dive in, we introduce our team. So we are a group of 6, which is Hazin as our lead, team lead, Nadira, Megat, and me, which is Eric, and Siti, Tika is our group members. So each of us contributed across different parts of the system. So why we want to have Gitbus? So in a typical campus, there are actually groups of people who is involved in the bus operations, and none of them have the tools they need. Students have no work of knowing whether a bus is approaching or not, is it running late, even operational or not. They wait blindly at the stop with no real time to play. It might become a frustrating experience, especially during peak hours. And for drivers, have no structural digital workflow. There are no system to formally start a trip, stream their GPS coordinates while driving, or close the trip properly. Everything is manual or ad hoc. While for admin also struggle. They also have no centralized tool to manage routes, assign bus to drivers, or monitor live fit positions. Everything is either done on the paperwork or scattered across different tools. So here, Gitbus solve all these problems at the same time. So let's talk about the main objective. So what Gitbus delivers? For admin, Gitbus provides a full angular web dashboard where they can create and manage routes, stops, buses, and drivers at home. They also can monitor live bus position on a map in real time. And while for driver, there are dedicated Ionic mobile app which driver can log in, select their assigned bus, start the trip, and from that moment their GPS will become live and streamed to the backend. And they finish the route when they end the trip, so the bus is removed from the live map. For students, another Ionic mobile app lets them see all the buses active on the live map. So they also can see their own locations and allow the system to show both buses and their positions simultaneously. So next, go to the system architecture. So this backend is built on modular monolith using Spring Boot. What does that mean? Instead of breaking the backend into many separate microservices, we organize it into 5 domain packages, which is auth, admin, driver, student, and tracking. Each package is isolated and handles its responsibilities, but they all live in one deployable Spring Boot jar. This gives the system to deploy simple while still being clean and organized. For mapping, we also use OpenStreetMap tiles rendered with OpenLayers, which is a free and open source. And the device GPS hardware on the driver's phone supplies the raw coordinates, which sends the backend tracking module and store as GPS pings tied to the active bus and trips. So for cloud infrastructure, we use GCP Cloud SQL, a fully managed Progress SQL instance of Google Cloud, as our shared persistent data store. So all 3 clients can talk to the same database through the same backend API. And for the security side, we use JSON Web Token S. So access token expire after every 1 hours and refresh every tokens at last 24 hours. So every API endpoint is protected by role. So admin endpoint will reject the driver tokens and the driver endpoints will reject student tokens. And we also configure global CRLS so that all 3 clients, web and mobile, can reach the backend without any issues. So next, let's go to the use case diagram. So in this use case diagram, we can see that there are 3 actors, which is admin, driver, and student. Admin can manage all fleet data like routes, stops, buses, and drivers, and monitor the live map from the web dashboard. While for the driver can authenticate, start and end their trips, stream the GPS coordinates, and view the live map from the mobile app. And for the student, they can authenticate, give the live bus, and also student positions on the map and manage their own profile. So all these 3 actors share the same authentication flow, like sign up, sign in, and also refresh token, since that is handled by the common auth module. So next, go to the backend and database. I will pass to the next person.
Hello, my name is Regin here, metric number 29665, and I'll be continuing with session 2, backend and database. So for backend, we use Spring Boot, and for database, we use Postgres. And in database, we have total of 11 tables, which consists of the users with users table, and the user table is used to store the credential of the user, admin, student, and driver. And then for student and driver table, we use to store the profiles. And for route, stop, bus, and trips is used for the functionality. And for bus location, student location, driver location is for the user GPS location. And then next we have refresh token to enhance the JWT, which I will explain it later. And next we have the ERD diagram for the database. And next we have we move on to the backend. So for backend, we use Spring Boot as a monolith. And overview, we have 4 modules. So first one is authentication module. So and we use JWT for the authentication. By default, JWT access token are have short lifespan, which means it will expire after 1 hour. So this is a problem if a user actively using the app and the token expired, they will get logged out. So we add refresh token to enhance JWT that will last for 24 hours. So when the access token expired after 1 hour, the refresh token will silently get a new access token for the user so that the user will stay logged in. And next is driver module for to start the trip and GPS tracking. And then next we have admin module, mainly focusing on CIUD for the route, stop, and bus. And next we have tracking module to track the user GPS location. And overview, we have this is the overview endpoint. So we have the public endpoint, which can be accessed by any user, type of user, and then we have admin specific, driver specific, and student specific. So what is mean by admin specific? So now let's look at the code. So let's say for create bus functionality, right? Only admin can create the bus. So that we implement the pre-authorized has role admin, which also mean that we implement RBAC, role-based access control, for the admin only, to allow admin only to create the bus. Now let's look at the Postman to test the backend. So this is the for the student to log in. Now let's send the request, and then the backend will respond with JSON response with refresh token, access token, and also the rows. And that's all for the backend and database. That's all from me. Thank you.
Assalamu alaikum. I'll be presenting for our CI/CD pipeline. So I will trigger the build. While the build is running, I will explain the process inside the pipeline. So the first phase is the Jira trigger. So when the ticket changes status from code review to testing, it triggers the Jenkins server to create a new build. First step is to fetch the latest code from the GitHub repo, and then I run three parallel processes. First, to build and test the Spring Boot backend, build and test the Angular frontend, build and test both mobile apps, the student and the driver. The reason why this is three parallel stages is because our virtual machine is strong, so we can save time by running those three steps in parallel. After that, the code is sent to SonarQube for quality analysis, and a summary of the quality report is sent to Jira as a comment on a static ticket. After that, the code is Dockerized to create the Docker image and uploaded to Docker Hub. Then the latest Docker image is pulled to the Google Cloud Virtual Machine and ran as a container, which is accessible from the web. After that, we build and save the APKs in a folder that is accessible by our application app APK downloader. And then we clean, the final step is to clean the temporary files and also the unused Docker images. So we can wait for the Jenkins pipeline to finish. So here you can see that the build is successful. Took about like 6 or 7 minutes. So we can confirm this by checking Docker Hub. So I check the image for the front end, back end, and the database. So as you can see, I updated 5 minutes ago, 4 minutes ago, 4 minutes ago. Okay, that's all for CI/CD. Thank you.
Next is the driver app. So this driver app, we're using an Ionic to build the mobile app for bus driver. And this driver app represents the trip management and live GPS tracking. Okay, in this driver app, it consists of four structures. The first one is login or register page. The second one is home page. The third one is the campus map page. And lastly, the profile page. For the trip lifecycle, the first thing that the driver need to do before they start the trip, they must select the bus. After they select the bus, the app will automatically detect the actual location for that driver, and the GPS will coordinate stream continuously. And for this app, one active trip was enforced for per driver. And when the driver ends the trip, the bus will remove from the map. Okay, I will show the app. So you can see, this is the Gitbus driver. The first thing that the user can see is a login page. And user also can create an account, which is register their details. But because I already create the driver, so I'll enter the registered driver. I will enter the first driver. Once the user enter the app, they can see the homepage first. The homepage will have like a greeting section, like a trip status, and also the quick access. As we can see, these trip status already in the live location right now. Okay, so these driver have been select the bus A. Okay, for example, I'll enter this first, and the driver can restart or ready to drive again. Once they click the ready to drive, they can move to this campus map page. Before this, because I already run this app, the first thing that the driver need to accept is the location first, because it will show the permission to detect the location. Okay, once they allow the location, they can choose the bus. For example, for this driver, I will choose the bus B, and I will click the start trip. Once it's start trip, the app will automatically detect the current location for that driver. For example, like this one. And this location will automatically update 8 seconds to the server, and the real user, for example, like a student, can see that the live location for that bus. Okay. For example, I will not end this trip for this first driver, which is the bus B. Okay. And I will log out and I will enter the second driver because I want to show that just only one active trip can be for one driver. Okay. This is the second driver. Okay. For example, I will start the trip and I will choose bus B, same as the driver, the first driver. Okay. And it will show the pop-up like this bus is already on an active trip. So it will prevent the duplicate trip. So I will choose like bus E and start the trip. So you can see this point is a route for that trip, and it will automatically detect the live location or current location for that driver. Okay, so if we end the trip, so the map is end and the bus will remove from the map. So in this profile, it is the driver can see their details, and I think that's all for the driver. Thank you.
First of all, my name is Nurul Nadira binti Zulkifli, and today I'm going to be presenting about the student mobile application for GitHub. So without any further ado, let's just continue. Okay, this is basically the overview about our application. So we have the app structure, map features, and location sharing. So the app features, the app structure that we have is login or register, and then home, map, and profile. And then we have the map features, which we have the live bus location, student position, OpenStreetMap, and pull every 10 seconds for updates. And then we have the stack, the still location. And then lastly, we have the location sharing where students can submit their own location, meaning that they have to open their location through their devices. And then we have location visible, and lastly, profile update, which is they can update their name, metric, phones, and address. So this is basically the overview about the app. So without any further ado, let me just open the app. Okay, this is basically the login account. So for examples, like if students don't have an account, they can just create account. They need to fill all the full name, metric number, phone number, home address, and then email address, password, and confirm password lah. So if for example, like I want to show the example, so I can just log in as usual, the test one. So for example, like I will log in as a student. Okay, this is the main home interface where where student can see a welcome greeting message with their name. So for example, like this is just a test. So if they input like the name, so it will be appear the names lah. And then we have the quick access for the student, making it easy for them, meaning that they can just click the bus map profile, my profile, and then the daily service hours lah. So for example, like if user click open bus map. So they can basically see the overall stop of the bus. If the student selects number one, so they can see, okay, number one is basically road C. So meaning that it is laluan C. And then they can also see the overall road. So they have two options, whether they can filter road only. So once they click show filter road only, and then they can see that, okay, this is the road of the bus, where the bus go. Second option is they can click the stop sequence. So this is explain the numbering just now, meaning that okay, stop one is basically at Inasis YAB or Muamalat, and then second is at the PKU, third is DKG1, and then fourth DKG6, and then lastly it's at DKG5. And they can just click hide stop. So all they can just go back to the overall bus route. And then we have implemented the hotline. It is for any emergency that happened when they need it, so they can just contact through the applications. So once they click the call button, they will be navigate to the contact, so they can just call. Okay, next we have the profile section. So this profile section is allow user to manage their personal information. So student can just click the edit profile, and then they can just edit their name. For example, like I put Nurul. They can click save changes, and then it will profile updated successfully. And then the names of before this, the name is Tess, and now the name is Nurul. And then okay, I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So now let's go into the admin dashboard module. So inside this module, the core of the dashboard is the security, where it will handle the session persistent via JWT authentication token, and it will store it inside the browser session. So we also have the implement an Angular root guard on all dashboard endpoint. So it will guarantee any unauthenticate users from our standard student from access the management features. And next, you can see here is the functional module inside the admin dashboard. So inside the dashboard, we have a route, we have stop, and we have bus where it will operate by using CRUD, which is the create, update, and delete operation function. So for each of their own perspective need. For road for the bus road, and stop for the CRG for the sequence ordering, and buses for their road assignment. Next, we also have a drivers and tracking module where for drivers it will show the list of any registered drivers of the inside the organization, and we also have a tracking where we can track. We have a live map of all the bus positions, so we can keep tracking of the ongoing bus. So as you can see here, we have the road of the road of the road. We have three, which is road A, road B, and road C. So we have the campus loop, coastal line, and also the library line.